And welcome to our water pollution unit, where we're going to be taking a look at the types, the sources, and the impacts of various water pollutants. We want to start our story here with the dead zones in the Gulf of Mexico, which are caused by the huge inputs of nutrients from the Mississippi River Basin. The Mississippi River Basin takes up much of the continental United States, going all the way up into the upper plains, through the Great Plains, much of the Great Lakes region, the Ohio River Valley, etc. And all of those nutrients from our nation's farms end up in the Mississippi River and then exiting into the Gulf of Mexico just past New Orleans. And so with all of those nutrients, you get these algal blooms. And so with these algal blooms, if I back this up, remember these algal blooms will form, which on the surface you might think, well, okay, they're actually going to increase oxygen because of photosynthesis, but that oxygen actually gets released into the atmosphere. What ends up happening, though, is all that algae dies and then sinks to the bottom. That's all food for bacteria, so the bacteria then decompose them, which uses up all the oxygen. And when all that oxygen is used up, then you have your dead zone. Now remember, the water has to be deep enough to have a thermocline, which we covered in a previous unit. And with that thermocline, the surface waters does not mix with the deeper waters due to a density difference. And so because of that, all that oxygen that gets used up in the bottom parts of the water never gets replenished, or it doesn't get replenished until later in the season. So in the meantime, you have a dead zone. Here's an aerial image just showing the discharge, and predominantly what you're actually looking at there is sedimentation that's pluming out into the Gulf of Mexico, and then due to currents is predominantly going to be heading to the west. But that also includes all the nutrients that will be causing the algal blooms. We did talk about algal blooms and dead zones in the Chesapeake Bay, which is on the right-hand side of the screen there. But more locally, we deal with dead zones in Lake Erie, which is in the central part of the slide here, the bottom middle there. And so what you'll notice, Lake Erie is actually divided up into three parts. You have the western basin, which is on the left-hand side of the slides, the eastern basin, which is on the right-hand side of the slides, and then the central basin, which is right in the middle. Now, the central basin is relatively deep. It gets to be a couple hundred feet there, versus the western basin, which is, borders Michigan. That's only about 40 feet deep. And so you'll notice that it always stays green, meaning relatively high in oxygen. And it stays relatively high in oxygen because it's so shallow that's constantly turning over. And so there's no thermocline, and so the water can constantly mix, and so therefore it doesn't get low in oxygen. Similarly, you'll notice on the right-hand side, it's generally high in oxygen in eastern Lake Erie. But the central basin, notice that it goes to about 0 in September, when all the algae that's formed along in the lake ends up sinking to the bottom, has been decomposing, and then therefore you get that dead zone. All right, more on that in just a little bit. So let's get into the nitty-gritties of water pollution. First of all, what makes something a pollutant? Well, it's anything that makes the water unfit for our use. All right, and that could be aesthetically, it could be for consumption, it could just be for something that we want to use the water for. Now, we've mentioned point sources and non-point sources before, but let's just quickly review. A point source is going to be easily identified, monitored, and regulated. In that case, we're looking at something like this, a drain pipe. This can easily be capped. Whoever's dumping it in there can be held accountable, and you can actually regulate that. In fact, we do regulate that through what's called the Clean Water Act. More on that later. Non-point source pollution, on the other hand, that gets a little bit trickier. That's broad, diffuse sources. You don't know exactly which parts are coming from which sources, although you have general ideas. But it's everybody. There's lots of different places that contribute little bits of this thing, and it becomes very difficult to control and clean up. So, for example, sedimentation is a very common, and in fact is the largest pollutant by mass of water. So now, where did this sedimentation come from? Well, partially it could come from the two farm fields that are adjacent to the waterway, but notice they actually do have riparian zones or buffer zones next to it. You also have sedimentation that's going to be coming from upstream, and then that actually gets carried downstream. So sedimentation is one of those non-point sources of pollution that gets a little bit more difficult to regulate. Now, what are the leading polluters from either point or non-point sources? Well, you got to go to the largest industries. Agriculture is going to be the leader in water pollution, simply because it's the largest industry. And what you were most concerned with is going to be sedimentation from farm fields. If they don't use a cover crop, there's times where the soil is exposed and it's going to be able to be run off into our waterways. And then also fertilizers, predominantly with nitrates and phosphates running off. And then pesticides. Pesticides both running off the fields, but also when they're applied indiscriminately, sometimes it just lands in our open waters. You also have industrial facilities, whether it's inorganic or organic chemicals. This goes all the way back to the opening of school when we talked about Minamata Bay and the Chizo factory dumping mercury into Minamata Bay. And then mining. Mining is a major operation, and there's a lot of waste, both from rock material, but then also the tailings, etc., that we'll be getting into, that contain toxic metals, and then they use a lot of acids to extract those metals, and so you have acid waste as well. So just to fix some images of what industrial mining waste may look like, particularly with mining, we'll give you some more examples when we're in that unit. This is showing a picture of a lagoon, a waste lagoon from a pig farm in North Carolina. So what you're seeing there at the bottom is a lagoon of both solid and liquid waste from those pigs. Now, where does that go? Well, what could potentially happen in those is the berms that hold that pond back. If those get breached, those can drain into local waterways. And if that pond is not lined properly, then that waste can leach downward through the soil profile into aquifers. So let's get into some specifics of our major water pollutants, and this is really what you want to focus on. Okay, so with this next slide here, this is a slide that you're going to need to be extremely familiar with. This gives you the major types of water pollutants, what their impacts are, and those are in the left-hand column. It gives you examples of what those pollutants would be in the center there, and then on the far right, where do these things come from? So let's go through these line by line. So first of all, you have infectious agents, things that cause diseases, where bacteria, viruses, protozoans, etc. These come predominantly from human and animal wastes. You could be talking about salmonella, you'd be talking about hepatitis A, you'd be talking about cholera, etc. Now, hepatitis A is something we've had an issue with here in the Detroit area over the past year. And unfortunately, what happens is employees will not wash their hands after using the bathroom. And if they have, and this could be from customers as well, but if you have employees that are not doing that and they carry out fecal matter with them and then they start working with your food, they can transfer that to the food that people consume. All right, and so that's a major problem right now. The next type of a major water pollutant is going to be oxygen-demanding waste. These are those compounds. They're going to be organic in nature, they're biodegradable, and they can be used as food by bacteria. And the problem with these is that they use up the oxygen that's in the aquatic system. These are going to be coming from sewage and animal feedlots, from food processing facilities, as well as paper mills. So just to take a look at that, in the upper left-hand corner, what we're looking at is food waste, and it's just giving you an example there. But anytime you're processing food, there's going to be waste material from whether, when you're cutting the food, whether you're washing the food, whatever the case may be, and a lot of that ends up going down the drain. Well, now that's food for bacteria. Similarly with, if you look in the upper right and lower left, you're dealing with animal waste and human waste, and that's going to be providing the nutrients for the algal blooms. And again, algae is going to be a food source for these bacteria. And it doesn't have to be in a lower, below the thermocline. We're talking about in rivers. We'll show you what's called an oxygen SAD curve, in which you get a temporary algal bloom, and then the oxygen drops, and then eventually gets replenished. And then finally, in the lower right hand, what we're looking at there is paper pulp. Now, cellulose-based items, that also will be food for bacteria. Next, we're dealing with excess plant nutrients, and this is going to be your nitrates and your phosphates, your NO3 minus and your PO43 minus. And again, those are going to be causing the dead zones. And those are going to be coming from, again, fertilizers. Now in the upper left-hand corner, we're talking about inorganic fertilizers, those pellets that get spread around the farm fields by spreaders. And then a lot of homeowners will do the same thing on their lawns. But then also human and animal waste in the lower left and then on the right-hand side there. Now again, those will cause algal blooms. So we mentioned the algal blooms of Lake Erie, and you can see from this slide in October from a few years back, the extent what we're talking about with these algal blooms is quite substantial. And so here's a close-up of how soupy that algae is. And once that sinks to the bottom, bacteria will chew it up, and you're going to be left with dead zones. Next, we're talking about organic chemicals. These are going to be carbon-based chemicals from hydrocarbons, predominantly petroleum products, oil, gasoline, plastics, pesticides, cleaning solvents. These are all going to be toxic to aquatic organisms, and they're used widely in industry and in agriculture, but then also around the house. If you take a look at these images on the upper left there, that's going to be an oil or gasoline slick. And that actually can be ignited. We'll show you in images later on of the Cuyahoga River that caught on fire. Pesticides being sprayed and eventually can get into our waterways, but this is not only in agriculture, but homeowners use these as well. In the lower left, plastics. Plastic pollution is a major issue, particularly in our oceans, but those are petroleum-based. And then cleaning solvents are those that if you're using organic compounds, oil-based compounds, you have to have organic and non-polar solvents, and they are used widely. You have also inorganic chemicals. These are going to be acids, bases, salts, those types of things. In mining, you use a lot of sulfuric acid to extract metals from their ores, and we're going to have a whole unit on mining. Here in the Midwest, we use a lot of road salt to keep things safe in the wintertime, but the amount of road salt that we put, a lot of that road salt is going to end up in our waterways. We also have sedimentation. We already showed you an image of sedimentation, but what ends up happening, now this is obviously going to be blocking the flow of water, but even if it's not quite this thick, the cloudiness of the water caused by sedimentation is going to block sunlight from reaching algae, and so it reduces photosynthetic rates, which is going to drop oxygen levels in the waterways. It also leads to thermal pollution because the light gets scattered amongst the soil particles. That heats up the water, which is not necessarily a good thing with aquatic ecosystems. We also have heavy metals. The three that you need to be concerned with is going to be lead, mercury, and arsenic. They come from a wide variety of resources. Predominantly going to be coming from industrial effluent in the upper right-hand corner through unlined landfills in the upper left-hand corner. People use them around the house. A lot of rat poisoning is arsenic-based. And then also in mining operations, and there's a wide variety of ways that those metals can end up in our waterways from mining. We'll talk more about that specifically in the mining unit. And then finally, thermal pollution. The deal with thermal pollution is that whether you're dealing with industrial plants or electric power plants, you have to have cooling water. And so the water's pumped into the plant, used to cool down, whether it's machinery, whether it's cool down water that's been turning a turbine. There's a variety of different applications there, but then that hot water has to be discharged into the environment. And so outside of power plants and outside a lot of factories, you're going to have a warm water discharge. Well, organisms have evolved to have a certain range of tolerance of temperatures. And so when you have higher temperatures, that's going to impact those ecosystems. You also have, with warmer waters, a higher incidence of bacteria and algae that can cause human health issues as well. All right. So those are the major sources of types of pollutants, the sources, the impacts. You need to spend some time thinking about those, and the rest of the chapter is really going to be working out some of the details regarding those.